Alright, we're moving on to section 2. We're just going to learn about some basic differentiation rules and looking at rates of change, because that's what a derivative is. We're looking at the slope. If you didn't catch that from the last video, we're looking at what the slope of, at any point in a graph, what the slope of the tangent line is. So we can find the rate of change of curve functions. First of all, one of the basic derivatives is taking the derivative of a constant. Well, the derivative of any constant in this first theorem says the derivative of any constant is 0, which makes sense. If we were to graph what the graph, it looks like the graph of a constant. So if I had the graph down here, y equal to 10, I'd be at 10 and it'd be a horizontal line at 10. Well, we're looking at the slope of a tangent line. So we're looking at the slope at any point on this graph. Well, the slope, say I want to figure out the slope from this point here and this point here, say it goes over 2. Well, my rise is 0. I don't go up any, but my run is 2, so I have 0 over 2, which is 0. No matter where you're gonna have 0 over something. So that's saying that your slope is going to be 0 throughout, and that should make sense to you. So the derivative of any constant is 0. In the same sense, y equal to pi. The derivative of that, pi is just a number, so the derivative of that is 0. The power rule. If n is a rational number, then the function f of x equal to x to the n equals n times x to the n minus 1. All that is saying is we're bringing down our exponent and we're subtracting that exponent by 1. So the derivative of f of x equal to x cubed is just 3x squared. We're going to subtract 1 from there. Just bring down our exponent, subtract 1. This function right here can be rewritten so it looks a lot easier for us. It can be rewritten as x to the 1/5. That means that it's the 5th root of x. So again, we can just bring down to find the derivative. We bring down the exponent and we subtract 1 from it. So we have x to the negative 4/5. Good. And in the last one, this function can be rewritten as x to the negative 5th. When you put a negative power, it just moves it to the denominator. So our derivative then, you bring down our exponent, negative 5x, and then we just subtract 1. Negative 5 minus 1 is negative 6. We could rewrite that as negative 5 all over x to the 6 as well. So those are the derivatives of simple power rule derivatives. Moving on, we want to find the slope of the graph of f of x equal to x cubed when x equals 1, x equals 4, and x equals negative 2. When we're talking about finding the derivative, we're talking about finding the slope at any point on that line. So when we find the derivative, we're finding ourselves an equation where all we have to do is plug in an x value, and that'll give us the slope of that line at that point, whether it's curved or not. So if we think about this for a little bit, we think about what an x cubed graph looks like. An x cubed graph looks like a disco dancer, if you remember. So we're going to look at, we'll say 1's about right. X equal to 1 is about right here. X equal to 4 is probably way out here. And then x equal to negative 2 is about right down here. All right, so we want to look at the slopes of the tangent lines at that point. If x equal to 1 is going to be right here. X equal to 4 is going to be somewhere up inside here. And x equal to negative 2 will be somewhere like this. So to find the slope at any point, we're just going to take the derivative. So f prime of x is going to give us the slope at any point on that graph. So it's 3x squared. Bring down our exponent, subtracted by 1. Now all I have to do is plug in my x values, and that'll give us a slope at each of those points. So where x equals 1, all right, I plug 1 in. So for a, the slope at x equal to 1 is going to be just 3. 1 squared is 1 times 3 is 3. And that makes sense. That looks kind of like a slope of 3. Go up 3 over 1. If you look at b, if we look at 4, 4 squared is 16. 16 times 3 is 48. And that's pretty sharp slope. So you're going up 48 over 1. That looks pretty much like we have graphed here, a really sharp slope, so that makes sense. And if we look at C, we plug negative 2 in. Negative 2 squared is 4. 4 times 3 is 12. So it has a slope of 12. I guess my graph was a little off over here. It should have been a little farther over here, I guess, to get a little steeper slope. So it has a positive slope of 12, up 12 over 1. The biggest thing is to know that when you take the derivative, you're finding the equation, so where we can find the slope at any point on the line. Find the equation of a tangent line. So we actually want to write the equation of the tangent line of the graph f of x equal to x cubed when x equals negative 2. Well, to write an equation, we need the slope, and we'll probably need a point that line goes through. So first of all, let's figure out the slope. Well, we know that f prime of x, to figure out the slope, we need f prime of x. We need the derivative, so 3x squared. To figure out what the slope is at x equal to negative 2, we just plug negative 2 in, and we get the slope to equal 12. Negative 2 squared is 4. 4 times 3 is 12. Now, we have the slope. Well, we probably need a point. Well, we need to figure out what the y value is. We have the x value. To figure out the y value, we just plug it into the original equation. So we have a point of negative 2, negative 8 when we plug that in to the original function. So now I have a point and a slope, which would lead us to believe that we need to use point-slope form. So point-slope form would just be, let's see, y minus a negative 8 equals 12 times x minus a negative 2. Cross the line, change the signs. So I have, just simplifying, 12x plus 24, subtract my 8, 12x plus 16. And that would be the equation of my tangent line of x equal to x cubed when x equals negative 2. Constant multiple rule is just saying that we can take the derivative of the x and then multiply by whatever that function is being multiplied by. To show you an easier way is just to show you to find the derivative of y equal to 2 over x. We can rewrite this as y equal to 2 to the x to negative 1. And what we do with the constant rule is just saying, well, when we bring this down, we just need to multiply it by whatever's in front. So the derivative, y prime, is going to be negative 2x to the negative 2 because we subtract 1 from the exponent. And we could rewrite that as y prime equals negative 2 all over x squared. All right. Again, for b here, f of x equals 4x squared divided by 5. Well, it's really 4/5 times x squared. That would give us 4x squared over 5. Take the derivative of this x, well, we're going to bring this, we're going to bring our 2 down, and we're going to take the derivative. So our y prime, or f of x prime, f prime of x is going to equal 8x, 8/5 x. So I brought my 2 times 4/5 times 2 over 1 is 8 over 5. I'm just showing you how I got 8/5 x. And then I subtracted 1 from my exponent. All right, to find the derivative of c here, we can rewrite this as just 1/2 times, we can say x to the 2/3. That means the cubed root of x squared, the same thing. So we can bring that 2/3 to the top. We can have 1/2 times x to the negative 2/3. And then all we're going to do is we're going to bring this down and multiply it and then subtract by 1 like we always do when we're taking the derivative. So our derivative, so 1/2 times a negative 2/3 is going to be a negative 2/6, which is a negative 1/3. So we're going to have negative 1/3 out in front. And we subtract the negative 2/3 minus 1. So this would be a 3 over 3. So it's going to be a negative x to the negative 5 over 3. And again, we can bring that down and simplify it. So we have negative 1/3 times x to the 5/3. Okay. And d here, again, we can simplify this as 5/2 times x to the negative 3, because we're just moving it on the other side of the division sign. Take the derivative of this, so I have 5 halves, and I'll take the derivative of negative 3. So negative 3, bring down our exponent, subtract 1, x to the negative 4th. So by multiplying these two, then I can have negative 15 over 2, x to the negative 4th. I can just bring that back down to the bottom and add x to the 4th. For e, with parentheses here, we have to do the parentheses first. So actually, we have to cube both of these. So to rewrite this, we had 5/8 x cubed. Well, to take the derivative, we need to take 5/8 times the derivative of 1 over x cubed, which is 5/8 times x to the negative thirds, x to the negative 3. Take the derivative of x to the negative 3, so I'm going to have 5/8 times a negative 3 x to the negative 4. So now when I multiply, I'm going to have 15, a negative 15 over 8 x to the negative 4, and I bring that down to the bottom, it turns into a positive. These last couple f and g here, this negative sign right here, all that negative sign means is to bring that to the other side, or bring that up on top of on the numerator. So this is saying 7/3 times x squared. All right, well, then I need to go ahead and take 7/3 times the derivative of x squared, which would be 2x, and then we'll multiply, I'd get 14x over 3. And this last one here, again, we have to distribute, so a negative 3 to the negative 2 and x to the negative 2. So I have 7 over 3 to the negative 2, x to the negative 2. This negative sign just means bring it to the other side of the division. So like above, when we had 1 over x, we could rewrite that. We brought it to the other side of the division bar and said it's x to the negative 1. Well, if we have 1 all over x to the negative 1, it just means that it's x. We bring it to the other side of the division bar. So what I have here now is I have 7 times 3. I want to bring it to the other side of the division bar, so it's going to be up on top now. All right, so 3 squared times x squared. So 3 squared is 9. 9 times 7 is 63 x squared. And now I need to take the derivative, bring down my exponent, subtract by 1. So 63 times 2 would be what? 126. And subtract 1 from my exponent, I get 126x. And the last thing, the sum difference rule is we can break up the derivatives and just take them all separately. So I can take the derivative of this function and add it to the derivative of this function, subtract it from the derivative of this function, and then add it to the derivative of this function. So we can take them all separately. So for a here, we drop down our exponent, so we'd have a negative 4x cubed all over 2, and that would cancel out to be a negative 2x cubed, right? Plus, we bring down our power and multiply, so it'll be 9x and subtract 1 from the exponent squared. And again, bring our 1 down. 2 times 1 is 2. When my exponent is 1, 1 minus 1 is 0. Anything to the 0 power is 1. So the derivative of 2x is just 2. And then the derivative of the constant is 0. So my derivative is of this entire function, so f prime of x is negative 2x cubed plus 9x squared minus 2. And the last thing right here is the derivatives of sine and cosine. Well, the derivative of sine is cosine, and the derivative of cosine is a negative sine. So in this first one, the derivative of sine is cosine, so y prime just equals to cosine x. And the last one here, we take these separately. The derivative of x is 1. Bring down my exponent, subtract 1 plus, and then derivative of cosine is just a negative sine of x. So hopefully this made sense to you. If it didn't, go ahead and watch it again. And I need to wrap this up before I run out of time for YouTube. Thanks for watching. We'll see you later.